Good morning to everyone. Myself, I am Suryanarayana, working as an assistant professor in PBR Bits Kavali in manufacturing process subject. Today in this class, I am going to discuss about Unit 2, which is metal forming. Unit 1 is also completed, casting process, and coming to Unit 2, introduction to metal forming. Metal forming process are also known as mechanical working process. Why we calling it as mechanical working process? Because of in this mechanical forces are involved. So for that reason we are calling it as metal working process as mechanical working process. Under the action of such forces, the shape and sizes of metal piece undergo a change. The shape and size are changes according to our requirement by using of mechanical force and application of heat. Next, by mechanical working process, the given shape and size of machine part can be achieved with the great economy in material and time also. Next, metal forming is possible in case of such metals alloys which are sufficiently malleable and ductile. Ductile is similar to elastic nature, easily deformable. Malleable, easily stretchable into a wire, that is known as malleable thing. Malleability is directly similar to plastic deformation. Ductility is similar to elastic nature. And next, plastic deformation. Introduction to plastic deformation. Plastic deformation is the final deformation or permanent deformation. After that the particular material will be break. Frequently, the workpiece is not sufficiently malleable or ductile at ordinary room temperatures, but may become so when heated. Next, we have two types of metal forming operations are there. One is hot and second one is cold. First one is hot working. What is hot working? And second one is what is cold working. Hot working, that is the process. In this, the process can be undergone above the recrystallization temperature. First of all, we know what is recrystallization process. That means recrystallization is the coarse grains are changed like new grains formation. That is known as recrystallization process. Single crystal is subjected to external force. It undergoes elastic deformation. For example, the behavior of helical spring before loading and after loading. That is pure example for elastic deformation. And next, if the force on the crystal structure is increased, that means after loading, ordinary loading, after again we are applying the load on particular element, it undergoes plastic deformation. First of all, elastic deformation, after that the plastic deformation. Elastic is reversible and plastic deformation is irreversible process. Elastic nature, after we releasing the load, that can be reversed back to original position, but in plastic deformation that cannot be regain its original shape or size. That is plastic deformation. It is the permanent deformation. The process of deformation comprises three types of natures: elastic, plastic, fracture. I was already told you about elastic deformation is the reversible process. Deformation of material power coming back, that means reverse back to its original position. When we are applying the load, that can be compressed. After releasing the load, that can be changed to original position. That is elastic deformation. And next, in this figure I am showing that first one, initial, small load, unload. In initial I am showing that the grains are the crystal structure before loading, initial, and after loading, that means after applying the some stress on particular structure, the bond stretching can be changed. That can be in this figure I am showing that with red color. After applying the load in terms of stress, after applying the load, after releasing the load, that is unloading, return to its original position or initial position. In this Keenly observe the first figure and third figure, both are similar. Before applying load and after releasing the load, both are same. Elastic means reversible process. Next, coming to plastic deformation, it is not a reversible process, it is a irreversible process and permanent deformation. Plastic deformation is important in case of forming, shaping, extruding and hot cold working process. And next, plastic deformation of metals. Initial, small load, unload. In this, compared to elastic nature, plastic deformation may varies. In elastic nature, we observe that first figure, third figure both are same. But coming to plastic deformation of metal, in this first figure and third figure both are not same. After applying certain load on the particular element, that can be changed, and that is the final deformation that cannot be changed like to initial or original shape. That means plastic means permanent deformation. Next, due to the various metal can be transformed into different products of required shape and sizes under the action of pressure, heat. The plastic deformation may occur by slip or formation of pins, deviation of regular positions of atoms, breakdown structure. Finally, structure after exceeding the load over the plastic deformation, that may fracture. First, coming to hot working. Hot working is the process is carried out above recrystallization temperature. Above recrystallization, that is hot working process. Recrystallization temperature in this at which atom mobility can be repaired, which any defect was present in the metal caused by the working process. That means new grains formation. After coarse grains are preheated, then any defects are occurred inside of the structure that can be repaired. That is recrystallization temperature or recrystallization process. Next, when the pressure is applied, the metal grain size will be varied. The metal's mechanical properties are also improved. After then, applying certain pressures on the particular element, also that materials are preheated. The mechanical properties that like surface roughness, toughness and finishing are also improved. If the pressure is applied by using hand hammers, that is known as hand or smith. After then, power hammers. Hand hammer is replaced by power hammers, then it is called hammer forging. Hot working is used for forging, extrusion and drawing. And next, when the metals are worked above the recrystallization temperature, it becomes plastic. That is the final deformation process. Advantages of hot working. It is applicable for mass production. Mass production, that means large volumes. The production may be done in large volumes. And next, the metal size and shape can easily change. Why? Because in this application of heat is there. By using heat, we can change the shape and sizes of any material into according to our requirements easily. Metal working is done under higher temperatures, therefore larger deformation is possible according to our requirement. I was already told you, metal grain structure will be refined. Stresses and other defects are minimized. Why? Because we are heating. It is a homogeneous structure, metal without defects. Next, mechanical, physical, chemical properties are improved. Gas pores and composition differences are removed. Metal reaches to anisotropic behavior. Hot working is very fast, reliable and economical processes. Disadvantages. Up to now we discussed about only advantages of hot working. Next, coming to disadvantages of hot working, it is costlier process. Why? Because in order to heat or preheat any material, we require some pits and furnaces and any other equipments, and maintenance is also very high. Hard working leads to poor surface finish due to oxidation, due to presence of oxidation. The material loses its strength. At higher temperature, sometimes it leads to lower strength due to loss of carbon content. Dimensional accuracy, also difficult to attain dimensional accuracy and uneven shrinkage of metal. Next, coming to cold working, we already discussed about hot working. The metal working process is done under above the recrystallization temperature, that is known as hot working. Below the recrystallization temperature, it is cold working. That means cold working, that is at room temperature. The process is done under room temperature. But compared to hot working, in this high pressures are required. Why? Because in this application, that means no heating process is there. The process is done under room temperatures. Soft, ductile and malleable metals can be easily worked with cold working metals. The cold working process used in this rolling, bending, spinning process, etc. Next, cold working process also affects the following mechanical properties of metals. Hardness can be changed, yield strength, ductility, tensile strength. Those parameters can be changed by cold working process. Why? Because here higher pressures are applied. By applying higher pressures, the parameters are changed, like hardness and toughness, roughness, yield strength and ductility. Ductility means deformation, elastic deformation. Tensile strength also increased. Advantages of cold working. Advantages, that means in hard working process, dimensional accuracy is very less. Hard working process, dimensional accuracy is very less, but in cold working process, dimensional accuracy is very good maintained. No heating of metals, that means the process is under room temperature. Better surface finish can be achieved since there is no oxidation process. That means we are not heating any particular metals. Strength of hardness of metals increased. Better strength and wear properties of metals can be achieved. Next, coming to disadvantages of cold working. It leads to brittleness of metals worked under cold working. Why it leads to brittleness? That means in this we are using the pressures, high pressures we are using here. After then, the certain deformations are occurred in particular metals. After exceeding of plastic deformation, that it can be leads to brittleness. Metal hardness is increased. Cold working components requires heat treatment process. Ductile malleable metals suitable for cold working. Greater force. Thank you students. Thanks for watching.